And this is 9.318. Okay, this we already covered this. This is where you use your cofunction, and I'm not going to write it because I'm in a lazy mood today. So I'm just going to use this as an example. And it's just, you're just going to use the cofunction. There it is. And the cofunction of cotangent is the tangent, and you just subtract it from 90 degrees. So this would be, what's the cofunction of cosecant? Secant. And what is 90 minus 11? Like 79 degrees or whatever, something like that. So that would be secant of 79 degrees. These are not test questions, but I can understand because you don't see them very often. So that would be, let's see if this is the same one or what. Again, that's the same one. And sometimes when you hit the send button, sometimes it sends it twice. Okay, this is 9.337/19. Cotangent. What's the cofunction of cotangent? Tan. And what's 90 minus 35? They go 55, so that's going to be the tan of 55. I think we covered that with slides. If I'm not mistaken, I think we did that with slides. Again, not a test question. It could be a standardized test question, but I don't ask these on my tests. I don't think I do. I could if you want me to, but not very difficult. The only reason people usually send them is because they haven't seen them before. So secant of what, 37 degrees? Or 27 degrees? 27 degrees, so that would be secant. 27 degrees. And you feel good about yourself. 18, 18, 18, 20. 20, number 20. First of all, is it a test question? No, not really. But 165 is over 90 degrees, right? But it's less than 180. So what's 180 minus 165? They go 15 degrees, so it should be 15 degrees. Okay, not a test question, but could be a standardized test question. That's number 20, 20, 23. Give the reference angle for the measure. Now, I will ask this question. So I need you to take your calculator and divide 1825 by 360. What do you get?
5.06.
Okay, so take 5 times 360. What is that? How much? And you get 25 degrees. So this one should be 25 degrees. Okay, we did a problem like this. I think we did, didn't we? I think we've done a couple of these. Because I wrote it out. 1825 divided by 360. Take that whole number, multiply that by 360, subtract that, and that's your reference angle. That is a test question, so make sure you know how to do that one. That's 23. This is 9.3, number 1. You should have put it in order. What is that one? Find exact values or expressions for the 6 trigonometric functions. This is a test question. I have no idea what this is, but if you want to find the sine, cosine, and tangent, let's go ahead and do that because that's a test question. I don't know what this is asking, but we'll go ahead and do it. First of all, they assume angle A, here is theta, so that means the little man is right there. So that means he has his foot on the adjacent and the what? Hypotenuse, and this is the opposite. So sine, cosine, tangent, cotangent, secant, cosecant. All you need is the first 3. Oscar had 3/5. A hunk, 4 over 5, of apple, 3 over 4. 4 over 3, 5 over 4, and 5 over 3. That's it. That's all I care about. I don't know what they're asking for. I wouldn't worry too much about it, but let's see, what are they asking for? They're asking you, instead of doing A, this side is AB. So what is, let's see, if we're given sign. Sign is Oscar had, so that's going to be BC over CA. So where is BC over CA? Huh?
A.
So are they going around the world? Yes. And if they ask all 6, that's just punishment. They're going to ask for all 6 like that?
I don't think so.
Oh gosh. Yeah, this is punishment. This is going around the world to go to Main Street. 3 over 5. So you probably sent this question just being frustrated. Whoever sent it, I'd probably get pissed. All right, so the cosine, A hunk, Oscar had A hunk, be BA or AB over AC. Where is AB over AC? B? And then they're going, oh my gosh. Are they going to ask for every single one? That's 12 parts. That's ridiculous.
Yep, sure is.
I don't pick the home. Well, I guess I did because I'm in charge of the home. So I guess I did do it. This sucks. Okay, Oscar had a hunk of BC AB. Which one's BC AB? Thank you. Okay, do y'all get it now? I'm not gonna do all 6 of them. I'm sorry. 1, 2, 3, 4. Okay, yeah, I hope y'all get it. Oh my gosh, that is so trivial. That is not what I did. That's a test question. This, I hope I do not. If I put that on the test, y'all have permission to throw something at me because that's ridiculous. Okay. All right. So, Miss Billy, did you get frustrated with it?
Yeah,
I figured you
a little
did.
bit.
Yeah, I'm sorry about that. All right,
I
that's.
got a little confused at first trying to figure out the sides, but now
Yeah,
that
if they'd have put X, Y, and R, or A, B, and O, or whatever, A, O, and C, A, O, and whatever, it would have been a whole lot better. A, O, and H. It would have been a whole lot better than doing what they were doing. All right, that's what question. That's number 1. So Lee, number 28. Don't know if we've been this far. Okay, this would be like a standardized test question. I wouldn't ask this on a test, but go ahead and just figure. I'm not going to do this, but y'all should be able to do this. But take 1560, divide by 360. What do you get?
4.
Multiply 360 by 4.
1440.
All right, subtract that from 1560. How much? 120. So everybody write down 120 degrees. 120, so that's your 60-degree angle. Okay, so that's, we'll go through and do it if you want to. But you got to remember, it's in the second quadrant. So is that going to change the signs?
Yeah.
Yes. Remember, you got to know where you're at. There's our 120. So we know that this one is 1, and this is square root of 3, and this is 2. But this one has to be what? Negative. And is that important for this problem? Yes. Because if you don't remember that little red negative, you'll get the whole problem wrong. Well, most of it. You'll get the problem wrong because 2 of them are going to be wrong. Or you can remember what?
All students.
All students take calculus and not worry about the negative and just apply the negative to the everything but the sine and the cosecant, or secant, cosecant. So I don't care what you do, but they just want these. So Oscar had, so here's our little man, and that's the opposite. That's the hypotenuse, and that's the adjacent. And I'm not going to worry about the square root because I'm trying to get as many questions as I can. So Oscar had the square root of 3 over 2. And cosine, Oscar had a hunk would be -1 over 2. And then tangent of apple would be square root of 3, negative square root of 3. Now that part is a test question. Okay? Anything with the 6 trigonometric functions or 3 trigonometric functions, it is a test question. Capiche? Y'all feel good about yourself? Okay, that's number 28, 28, 29. To 25. Okay, find the exact value. Well, first of all, what do you do on this question? You got to find out where you are. Now, remember, I teach to people that are not water walkers. I think there's at least 2 or 3 people that you need to explain things to. So that's why I say make sure you know where you are for those people that have never had trig before. So 5 pi over 4 multiplied by 180 over what? Pi. And what happens to the pi's? And 4 will go into 4 times 45, right? Y'all check me. And 5 times 45 is what? Dang old 225, somebody check me.
Yeah.
So somebody tell me where I am.
Third quadrant.
Third quadrant. All students take calculus. So everything except for the tangent and the what? Cotangent are positive. Everything's negative except for those 2. So you know, I'm scared I'm going to hit my ankle again. The tangent is positive and the cotangent is positive. So therefore, all the others are going to be what? Now we also know this is a 45-degree angle, right? 45-degree angle, 1, 1, square root of 2, -1, or you don't need to worry about it because you already established that with all students take calculus. So now you just do, here's your little man. Dang old Pennywise. Anyway, that's opposite and adjacent, and there we should be able to knock it out. And a lot of these questions were sent before we probably went over this stuff. So the sign, what would the sign be? Oscar had 1 over square root of 2, which is the square root of 2 over what? 2. Same thing for the cosine. And then what would be the tangent? 1. So hopefully you should get that. The number one, when you're talking about this section, the number one thing, find out where you are. That helps a lot of students, believe you me. Helped me. All right, that's 29. 30, probably the same type of question, but we'll check it. Okay, all right, now, if you can't do these, then we need to talk, okay? These are calculator questions. Make sure they're in degrees, degree mode, okay? I had an email this morning about degree mode. So make sure, you know, if somebody give me 4 decimal places, please, and we'll just, and again, these were probably sent before we even talked about trigonometric functions. So what is 24 degrees tangent? Point what? And that's all there is to it. For those of you that, and I'll go through it right quick. I don't know how much I've done on the calculator in here, so pull up the handy dandy calculator. Make sure the mode is degree. How will you know if you're not in the right degree? Well, I'll show you. If you type in, what was it? Tangent of what? Tangent of 24. Tangent. I can't even see on this thing. Which
To
one's
the right,
tangent?
and then down one.
Travis, no, I
Down
can't
one
see.
row.
The blue. See the blue? You can't see it. Right here.
Down one row, and then over two.
Right here.
And then over two.
Oh, I'm sorry. I was looking above. I'm sorry. I was looking above. I wasn't even looking at the letters. Sorry. I suck. So what was it? Sign of what?
As tan,
Tan of
24.
24 degrees. Watch what you get. It's going to give you a negative. Okay, that's not right. Okay, you're always going to get a positive when you're talking about tangent. Okay, especially when it's in the first quadrant. So let's take it. It's always going to be a small decimal. So mode, degree, and if you keep typing in the wrong answer, something's wrong. So, and now we're going to do second entry, clear, second entry. There we go, and enter. There you go. Is that a standardized test question? Yes. Could I put one on my test? I could. I don't know if I have any, but that's one I could put on there because do you use this in the real world? Yes. Especially with engineering, surveying, you use it because you're always trying to find the vertical height or you're always trying to find a horizontal height or horizontal distance going up a hill because the vertical distance, the hypotenuse, is always going to be what? The higher, the highest distance or whatever. I can't even think right now. The horizontal distance is going to be smaller than the what? The hypotenuse. So when you're doing a vertical distance up a hill, you've got to find the horizontal distance. You use tangent, sine, and cosine. So there's a lot of application in surveying and engineering in the field with, or unless you're going to be a sniper, then it'll help too if you're going to be a sniper. Yeah. Is that a bad word? Can I say sniper? Is that a bad word? Or do I offend anybody?
You're good.
Okay. Nobody's offended, right? Sniper? I don't want to offend anybody, I hope. Pendleton, settle down. They're on fire. I just don't know what I'm going to do. I'm going to have to call security on them. They are listening. Okay, that's a good thing. I have no idea where I'm going. Okay, here we go. Okay, these questions. Okay. I'm sorry, I'm a guy. I can't do three things at one time. All right, so 30, 31. I feel like I'm doing y'all's homework for you. But I will. Okay, this one. What's the secant? It's the what? The reciprocal of what? So I'm going to do 1 over the cosine of 43/24. Now this, a lot of people probably have not seen this before. So the best thing to do is to write this as, this is over 1, and 1 over the cosine of 43/24. Now that is a legitimate question because we haven't done anything like that, but it's the reciprocal. If you use your reciprocal rule, then you just find the secant and then put it over 1 and divide it, and that's the same thing. You can do it with a decimal, or you can put cosine of 43. I don't care how you do it, you're going to get the same answer. Let's see how they show it. Do they do the decimal first? Let's see what they do. No, they do it just like I do. Okay. What do you mean decimal? Well, you could change it to a decimal. That still wouldn't work. It'd be better to do it this way because then you have to convert it. So just do it this way. Okay? Feel free to speak up. If Pendleton will be quiet, you know, hopefully if you got a question, just spit it out. This is that same one? Thank you. 31, 31, 31, 32. Okay, same thing. Sine of 1.7536. So pull it up. Sine of 1. I guess y'all thought I was blind as a bat, didn't you? Right there. I wasn't even looking at the keys. I was looking at the blue. I was thinking of inverse sine. I guess y'all thought I was drunk. I'm not drunk yet. 1.7536.
Do what?
0.0306.
This second.
I guarantee you, most people that have these questions, I bet you their calculator was in radian mode. But you don't have to say anything because that's usually 0.0306. What did I do wrong?
This one asks you to put it in radians.
Where does it say that?
If you go to question example, view an example.
No. It should not do that. They don't have anything here telling you to do that.
I put it
No,
in
that's a bad question. Okay, it has to be in radian mode. Okay, write this down as a bad question because they don't. What tells you to do that here? I guess because it doesn't have a degree. I guess they're saying, okay, well, y'all are supposed to know this, that we don't have a degree here, so you're supposed to know that it's radians. I guess that's why.
Yeah. So.
Yeah. It's not a good question. I would not use it on the test. So let's go over to mode, change it to radian, and type in sine of, and I didn't pick it up when I looked at it. Sine, I'm still looking for sine. There it is. Sine of 1.7536. Now, why else would I not put this on a test? Because nobody ever asks you in the real world for the sine of a radian. Nobody. Unless you're in academia teaching a math or a physics course, and even physics doesn't use it. Only time physics uses it is when they're talking about revolutions. Not a big fan of radians, as y'all can tell. You do? Why?
I like ratio.
You like fractions? Okay. Okay, you are strange. No, I'm just kidding. Poor old Horatio. All right, this is question number 4. How did that? I think we've already covered this, but we'll look. Yeah, we covered that the other day. So I got that one. That is a special angle of 135. What angle is that? 45 in the what quadrant? Second quadrant. All students. So that means that the sine is positive and the what? Cosecant is positive. The rest are negative. So make sure either you do that or you put it in the 45 in the second quadrant and draw a -1 on the bottom, +1 on the side, and a square root of 2, and you should be able to fill that one out. I'm not trying to hurry. I'm just trying to get to 9.4, okay? Because that's going to make up probably 70% of your test. Okay, so there's 9.4, and I'm just going to stop there, and I'm going to switch over to the Now, why do I care about this section? Because it's real world. And I like to teach real world problems. Now, are these a little bit cheesy? Yes, and I'll tell you what I mean by cheesy in just a minute. Because they do round everything to the whole number, and they give you, but I'll tell you where it's not. Can y'all see my board okay? I guess y'all could. Y'all done said something. Okay, so I'll move on. Okay, degrees, minutes, seconds. I don't care about this because in real life, degrees are 2, minutes are 2, and seconds are 2. So I don't really care about what they say, but that's up to them. Here is a problem, and we might have touched on this before we left. Okay?
We did.
We left. Did we?
Yeah, a little bit.
I think we did this one. So write this down. This is a test question. Anything in this section is pretty much a test question unless it has like 15 parts, and then that's really not very smart. Okay? But let's write this one down, and of course, we're going to fill the puzzle out. And I like to tell people that it's just like a puzzle. You've got 2 knowns, and you've got 1, 2, 3 unknowns. You've got a side and an angle, but you've got 2 sides and an angle that are missing. Now, you can actually find the angle first. Okay? You can find the angle by saying 180 minus 90 minus 3430. And that will give you angle B. So somebody take 180 or 90, take 90 minus 3430, and that's going to give you 4530 or 5530. 5530. So we know that that angle B, y'all smell popcorn?
They have it out there.
Is angle B. All right, so there, now that we just used the theory of a triangle. How many degrees are in a triangle?
20.
Total degrees. 100 and what? 80.
If we wrote that as 55.5 degrees, would you be okay with that?
It would be 55.5.
Yeah.
Yeah. Remember, I don't care about that unless the directions specify. If the directions don't specify, I care less. Now, I do like it in degrees, minutes, and seconds because that's real world. But, you know. Now, let's find, now you could do, and I'm just going to show you, you could actually go to angle B now, and you could find the sides with angle B or with angle A. Since the slide is going with angle A, I'm going to go with angle A. And I'm going to say, okay, let's see, we've got little man is right here. Who's match? Isn't that nice? So this is our adjacent, this is our opposite, and this is our hypotenuse. Oscar had, so we can do Oscar had, that's the sine, right? So the sine of 3430 is equal to Oscar is A over, and I hate your choice of letters here because it just messes everything up, over 12.7. And now use your algebra, multiply by 12.7 on each side. And somebody tell me what sine of 3430 in degree mode times 12.7, what is that?
7.9.
7.19. Did I get a second? Everybody get that? Now, can I find the third distance not using trig? Yes, I could use the Pythagorean theorem. Or I can use the cosine. I don't care how you do it. Go ahead and do it. You can do 12.7 squared minus 7.19 squared, and then take the square root of it, and that'll give you the b. You can take the cosine. Cosine is equal, Oscar had a hunk, and that would be a over 12.7, multiply both sides by 12.7, and that will give you the same answer. And that's what this section is. That's all this section is. Now, they're going to make it a little bit more difficult. Try to get you discouraged to quit. Here we go. And there's another one. Here they give you the opposite side. So where's the angle? Well, it doesn't matter. You can put the angle wherever you want to. If I want to put the angle up here, my little man's up here, then this is the adjacent and this is the what? Hypotenuse. If I want to put my little man here, then this is the adjacent and this is the hypotenuse. I'm going to put it up here. Why? Because I have two what? I have two sides. Now you just have to figure out which side do you have. What do we have? We have the adjacent and we have the what? Put your little man here. You have the hypotenuse and the what? Adjacent. Now this is, I wish they call that one O, call that one O. All right. So, which one? Oscar had a hump. So it's the what? Cosine. Cosine of theta is equal to what? Oscar had a hump, 2943 over 53.58. So we got to solve for the theta, so I'm going to divide by cosine, that's to the first power, divide by cosine to the first power. If I bring that cosine up, that's going to make it what? Inverse cosine, -1 of 2943 over 53.58. Now work that out. Now, do you have to go up here? No. But the reason I'm not going down here is because here I don't know an angle. I would have to, if I wanted to use this angle, I would have to use the what? The opposite over the what? The hypotenuse, which would be Oscar had, I would have to use the sine. So then I would say, I'm going to do this in rouge. What do you say? Habla español. Red. No, that's not the way you say this. ¿Cómo se dice red español?
Rojo.
Rojo. Dang old Rojo.
Yup.
Dang, I remember that. Dang old Rojo. Oh, and why do people on Facebook use a utensil to spell hoe? It's not H-O-E, dumbasses. It's H-O. You know, like a hoe. They use the garden utensil you weed with. It's very ignorant when you're blessing somebody out and calling somebody a garden utensil. Don't do that. That's hanging a sign around your neck that says I is ignorant. Okay? Don't do that. For those of you, that's a hoe. You know, like Santa Claus, ho, ho, ho. This right here is a garden utensil. I don't know what made me think of that. I'll shut up. trying to get something out of Pendleton, of course, nothing. Get nothing out of him. Queen on a pickle. Okay. Here, I'm going to get theta. I'm going to call this theta. Okay, that's theta. And I'm going to say theta. I'm going to use what? Well, I'm putting my man down here. So that means I've got my adjacent here, and my hypotenuse is here, and my opposite is here. Oscar had. So that's the sine of theta is equal to, no coughing in class. Heck gone. You need to lay off the Marlboro Reds. All right, Oscar, 29.43 over 53.58. And that's going to be the inverse sine. So theta, all right, theta is equal to, all right, somebody give me the inverse cosine of in blue. What'd you get? Somebody give me, what'd you get?
6.6.
I'm sorry, what?
56.68.
That's good enough. and somebody give me this in red. Should they be the same? Not really, because they're two different what? Two different angles.
You're at 33.32.
32 point what?
33.32.
33.32. Now add those two up and see if you don't get 90. It's a miracle. Now, why did I show you all this? To confuse you? No. I'm trying to tell you, if you put the little man where you need to, you can't go wrong. But what happens is, students don't do that, and they're trying to figure out they just don't know what to do. Remember, you got to know where you're at in this first part of trig. You've got to know where you're at, either the angle on the unit circle, or you got to know where you're at as far as the trig, as far as the triangle. Where are you? It doesn't matter. I could ask for angle B, or I could ask for angle A. It doesn't matter. You just got to know what's what. Capiche?
Peace.
Comprende? I like capiche because it's Italian, and I like Italian. I'm not Italian, I'm not South American, I'm not anything like that. Guess what I am? No? I mean, nobody's American. You got to have something in front of it, like, you know, blah, blah, blah American, or blah, blah, blah American. So, you got to guess what I am. Anybody?
Irish.
I am very majority mother, father, grandmothers, grandfathers, Irish.
Oh.
You have to look. You have to Google Black Irish. Yep, I'm black. Black Irish. Look it up. You don't believe me? All right, I'll show you. You don't believe me? I'll look it up. I'm just trying to waste time, people. Go with it. Dang old Black Irish, y'all don't believe me? Dang old, y'all know what y'all are being? Y'all being racist is what y'all are being. Why? Irish, look here. Tell me I'm not crazy. Y'all learned something today, didn't you? Racist. 1500, dang old 1500s. So y'all learned something today.
He's from the Spanish army, though.
What?
Said something about Spanish.
Yep. Well, yeah, Spanish. I guess I am Spanish then. But they call it Black Irish. And the reason I know I'm Black Irish is because my dadgum aunt, she's like a genealogist. She had me do a DNA test for dang old, what is it, Ancestry, back before it got all popular. And that dang old Irish.
You think those things actually?
I don't know. It was pretty accurate because when they sent me my results and I went to the website, it was putting out names that I have in my notebook that I've gotten from family, and I've not put it on. So it was pretty accurate. I didn't read that. I didn't know that Spanish Armada thing. I don't know about that. Oh well, I'll have to look it up. I've never seen that before. I've seen stuff down here. I'll have to look it up. I didn't know about Spanish Armada. That could have happened, you know. That dang old boats, dang old Ireland, dang old island.
Yeah.
Could have happened.
Lord.
Dang old ancestors. All right. Let's look at the time. What time we got? We still got till 12:35, so we got plenty of time. So let's finish. Let's go to. Y'all gonna be ready for a test pretty soon. Oh yeah, that means y'all have to do your homework. Look at there, we got it right. Now there is the Pythagorean theorem. If you have to write it down and you're in trig, go ahead and write it down. That's it. And of course, that's how you use the Pythagorean theorem. And that's it. Now, this is called the angle of elevation. What is the angle of elevation? In the real world, you got two angles. You got a horizontal angle and a vertical angle. In academia, the vertical angle is the angle on top. When you got two crosses, when you got two lines crossing, it's the angle on top. But in the real world, an angle of elevation is also called the vertical angle. When do you use a vertical angle? If you're staking out a road and you have a hill and you're going like this, the contour of the hill looks like this, then you have to shoot with your transit, you have to shoot this angle, and then this angle, and then this angle, and then the angle that goes right there, okay? These are called vertical angles because these are not curves, these are hilltops, okay? So you've got to shoot this vertical angle, and then this vertical angle, which is going to be a negative vertical angle, okay? We'll just call it theta. And then this angle is a positive vertical angle. And then this angle up here is a negative vertical angle. So does everybody understand what a vertical angle is? The vertical angle goes 90 degrees from 0 to 180 degrees, positive 90 being above, negative 90 being below, or negative angles. Now, of course, this is academia, so they'll probably turn it around the opposite of the real world. So vertical angles, think of valleys and what? Hilltops. Okay, angle of depression. This is called a negative angle. Negative means you're going what? Downhill. Positive means you're going up. This is a positive 0 to 90. This is a what? Negative 0 to 90. Now I'm trying to tell you in the real world because, like I said, if you walk up to a civil engineer and say angle of elevation and angle of depression, they're going to look at you like, when did you get out of school? Okay? Because that's not used in the real world. It's a negative angle and a positive angle. Okay, this is a practical application problem. This is what you call cheesy. Okay, but I will tell you how I've used this in the real world. Okay, I was running a water line in Williamston. Okay, Williamston. Okay, if you're from Williamston, that's the way transplanted people say Williamston. They don't say Williams. Williamston is Willmston. Williamston. Okay. So anyway, I was doing a water line up there, locating it, staking it out to be dug, and we had to figure out the height of the water tower. The water guy was there, the water engineer was there, and he didn't know. We were talking about doing something, and he didn't have his plans about the water tank, the height of the water tank. You know, the big water tanks. And I said, well, we'll just shoot it. It's right there. We'll shoot it. And we shot it. Now, did my crewman, did he climb that water tower? No. He did exactly what we did right here. Okay? We shot an angle to the top of it. And then I got a vertical distance to the bottom of it. And I could tell you with the angle that I turned, the vertical angle, I could tell you the height of the water tower. Now, to some of y'all, that might be interesting, okay? Because it is interesting how you can tell the height of something and not even climb it, okay? So this is how you do that. So the length of the shadow of a building is 34 meters tall and it's 37 meters. Find the elevation of the sun. This is, you can do whatever you want to, but you've got the angle here. You don't know the angle. But I'm going to give you a problem like that. Okay, there's the angle. We'll call it theta. And theta is equal, you've got adjacent here, you've got the opposite here. Oscar had a hunk of what? Apple. And when you're dealing with the height of something, you're going to use the tangent. Oh, I didn't. When did that get there?
When you were trying to tune up your tent.
Oh, okay. I'm sorry. So you're going to put the opposite over the adjacent, and then you're going to do the inverse tangent. Now, what if I was to do this? Just ignore this right now. If I was to, let's say if I had a water tank, if I can't work this jet plane thing, I'm about ready to quit. Let's say we have a water tank. Okay? And that water tank is, I can't remember, I want to say 750 feet. 750 feet, and I shot a vertical angle of like, I can't think now, I think it was around 101, 102 degrees, I can't remember. That's been, 20 years ago. 102 degrees. No, it wasn't 102 degrees, because it has to be between 90, has to be, might have been 82 degrees. 82 degrees. What is it? 82 degrees. Yeah. So I want to find the what? What is this side called? That's the opposite, right? Because you got your foot on your what? You got your foot on the adjacent and the hypotenuse. Oscar had a hunk of what? Of apple. So the tangent of 82 degrees is equal to the opposite over the what? 750. Does somebody multiply 750 by the tangent of 82 and tell me what you get? Well, I must have had the angle off. I can't remember the vertical angle I turned. Well, what did it come out to be?
5336.
5336? Okay. So, of course, the water tower is not 5,000 feet. I just couldn't remember the vertical angle I turned.
Oh wait, I did that. That's my.
Somebody tell me the right answer.
That's what I got.
Okay.
Yeah, I did it twice. I just didn't believe it because it's so big.
Okay, try 12 degrees. 12 degrees. Do 12 degrees times 750.
85.
Huh?
85.
Okay, it's between 12 and 82, somewhere in there, because the water towers are standard 70 feet. You said it was 82?
Yeah.
Okay, that would have been about right.
So that's what I did.
So you can tell the vertical, if you can pull the vertical distance.
All the same color.
Okay, let's do one more. Let's check the time before people start exploding. I worry about Pendleton because I'm scared they're going to explode. What time's class over? 12:35. Mandy, what time's class over? Because I trust you.
35.
Okay. I don't trust people. Now, here's where we're going to get on the bearings. Now, it's very important that you understand what a bearing is. A bearing is off of north. Write that down. A bearing is off of north. Actually, that's a zenith bearing, but we're not going to talk about that. Because in the real world, a bearing can be off of north or off of south. If a bearing is southwest, it's in the second quadrant. Southeast, it's in the second quadrant. If it's southwest, it's in the third quadrant. If it's northeast, it's in the first quadrant. If it's northwest, you're in the fourth quadrant. It's exactly opposite of academia. Okay? So, what is that?
Nothing.
Oh, I thought that was a math book. I thought that was a math book that came with this class. That's why I was asking. You can go ahead.
I'm good.
Okay, so 32 degrees, that's in the first quadrant. 164 degrees is in technically the second quadrant. That's in the third quadrant, that's in the fourth quadrant. But I don't want to mess y'all up by saying the quadrants. But I'm going to tell you, if you go in the real world, it's the opposite. A bearing is always off of north or south, depending on your context. And with navigation, a lot of times, especially with land navigation, it can be off of north or south. But in these questions, it's going to be off of north. Now, you've got to think on these questions. You can't just gaff it off. You're going to have to actually think. If I say that I go horizontal, horizontal is 90 degrees off of what? North. So you can't just throw things, aside and say, oh, well, you got to read. I know some of y'all, read. You have to read, kind of like my handouts. You have to read them, okay? Radar stations A and B are on an east-west line. That tells you that that's 90 degrees from the north, okay? With A west of B. A west of B. 3.7 kilometers. Nobody uses kilometers. Okay. And the rest of the world uses kilometers, but the U.S. don't. We use miles. But anyway, 3.7 kilometers. Station A detects a plane at sea on a bearing of 61 degrees off of what? North. So you have to start thinking like that. 61 degrees off of north, because it says bearing. Station B simultaneously detects, that's at the same time, detects the same plane on a bearing of 331 degrees. 331 degrees. Find the distance from A to C. This is a test question all day long. It is also a standardized test question. So, what do you do first? Well, the first thing you got to do is figure out what the angles are. What do you mean? Well, this is 270 right here. How do you know it's 270? Because of this word right here, east-west. This is 270 degrees off of what? North. This bearing is what? This bearing right here is 331. So what's the difference between 331 and 360? 29 degrees. That's alternate exterior angles. Alternate exterior angles mean that this is 29, then this is what? 29. And of course, now you can use this angle as 61 degrees. That's alternate interior. If this is 29 and that's 29, then this 61 is this 61. And now you're ready to figure your angles. Now, do you see how the question dictates what to do here? You don't have to do anything but read the question. And of course, now you do all your sine and cosine and fill in all the blanks. Here's another one. Okay, they have to go through all this. Okay, let me get to the next question. See, there's the second part of bearings. This is the part that I will test you on. Northeast, north 42. Southeast, south 31. It's coming off of north and south. Okay? And this is the type question I will give you. Write it down, and you can work on this one, and we'll start from this when class starts again. The bearing from A to C is 52 southeast. So you draw 52 southeast would be down this way. The bearing, it's A to C. You do A, and then you do C. A to B is northeast, so it's going in this direction. So already I know that I've got a line going. Here's a line. That's north. And I'm going to just put a dot here, and we'll call this A. South, 52 degrees. I'm just going to assume 45. I'm just going to just do that. And I'm going to put a line here that says south to east. And I'm going to put a dot here, and I'm going to put C. And then I'm going to draw 84. Well, 84 degrees is almost what? It's almost what? 90? So 90 is right there. So I'm going to put 84 right about there. And it's what? A to B. Bearing from B to C is south 38 degrees west. South 38 degrees west. I'm assuming, south 38 degrees west. And this is 84 north, 84 degrees east. Everybody with me? Find the distance from A to C. So they want to know the distance. And I'm going to draw that in red. They want to know this distance from A to C. Now, do you look at the triangle and say, well, that doesn't look like? No, you do not look at the triangle and assume anything, because this is not the scale. Okay? Now, you also fill in the bearing from B to C. A plane flying at 250 miles per hour, so that's the magnitude. 2.5. Okay, you can figure that. Let's see, from where? A to B. So this is 250 miles. And it took, what, 2.4 hours? I'm just writing that down. To go 250 miles. Oh, I'm sorry. 250 miles per hour takes 250 hours. Why did they do that? Okay, distance equals what? Distance equals rate times time. Distance is equal to the speed, 250, times what? 2.4. Somebody do that for me. Get 500. 1% would be 2.5. 4 would be 10. So that would be 510. Help me out. 610? Or I don't know. What is it? 600 even?
Yes, sir.
Okay. So 600 miles, if y'all did that correctly. So 250 miles per hour at 2.5 hours is 600 miles. So now you've got, now if you will do something over here, you might find that one of your angles is 90 degrees. So let's do this right here. 84. Let's see, this angle right here is there. So I'm going to do 180 minus 84 minus 52. Somebody do 180 minus 84 minus 52. What do you get?
44.
So that angle is 44 degrees. And then this angle over here, 38 degrees. Let's see, 38 degrees. We're going to have to take 180 minus 38. I hope I got this thing drawn right. There's something else in here. Well, we ain't got enough time to start it right now. But go ahead and write that one down and start working on it. And we'll work on it when y'all get back. They draw a better picture. I'll show you the picture they draw. Probably. Okay, it looks kind of like mine. The 90 degrees at C. I knew there'd be a 90 degree somewhere. Okay? So there's, you put in 90 degrees at C and you should be able to work it. And I'll show you how to get that when we come back. Whatever day we come back. When is that? Thursday. Okay, how many people we got up there at Pendleton?
Nine.
How many?
9.
Okay, y'all are 111. Are they 12 or y'all 12?
12. We're 12.
Okay. Y'all got 11?
We have
1, 2,
nine. We have
3,
9.
4, 5, 6, 7, 8, 9, 10, 11. How many y'all got?
9.
Does anybody know who's missing? Okay, Dawson,
Here.
Farrell,
Here.
Fuller,
Here.
Green, don't leave yet. Jackson,
Here.
Long,
Here.
Patel. No Patel.
No, she's saying here. Her voice is hoarse.
Well, she needs to bang on the bang on the desk. No, I'm just kidding. Miss Patel is here. Payne.
Not here.
Not here.
Seabrook. Seabrook.
Not here.
That's it. Okay, Pendleton and everybody else, y'all need to be working on your homework, but you should be working on 9.4 because we started it today. You might not be able to finish it. That's okay. Pendleton, you can go. Easley, you're missing somebody. Who you missing?
Yeah.
Let's see, let's see who this is. Okay, that's, Oconee.
here.
Oconee's all here. Oconee, you can go. 1, 11, 9. Who we missing up
Yeah.
there, Miss Billy?
Zach.
Zach.
Okay, we're missing Zach. Okay, y'all can go. And of course, Anderson campus. Are we missing anybody? There's 4 of you. There's 5. We're missing Elijah. No, we got Elijah. Who are we missing?
Maybe Andrew?
Who?
Andrew.
McCarthy? Okay. All right, y'all get out of here and work on 9.4. Glad y'all got to see me today.